Today the lesson is complex numbers. Before we go into define what these complex numbers, we'll just see what are numbers in mathematics that we all know. The numbers in mathematics, that is, for example, say 1, 2 or 3 or 4, like that up to infinity, we say they are positive numbers, and then of course we have negative numbers as well, -2, -3, -4, like that down to negative infinity. These are what we normally call as numbers. Mathematicians wanted to explain this quantity square root of -1. Now we all know that square root of a positive number is easy to understand. But what is this? Now square root of, say, +4, we know is equal to ±2. So that means if you square +2, you get 4, or even -2, if you square it, you still get 4, because -2 times -2 is +4. So similarly, say square root of 81, we know that is ±9. But to define square root of -4 is not that easy. So what is this? Because of the negative sign there inside the square root mark, it's not easy to define it. So what we do is, now here we first define what is square root of -1. Now this is not a real number, so we call it an imaginary number. And first, when we started this complex numbers, we said that is equal to I denoting that it is imaginary. But later we define this as J, because we didn't want to mix this I with the I that we use in electrotechnology. In electrotech, we use I for current. So we didn't want to mix it with the current, so we use J instead, because it's easy. So if J is equal to -1, then if you square both sides, say -1 square, and J, if you square both sides, the equality holds. So that means J squared is equal to -1. So this is a fundamental relationship in these complex numbers. So now we can actually define what we could not define earlier, this square root of -4. So let's write this again. Square root of -4 can now be written as square root of -1 times 4. Now it is +4, because -1 times +4 is -4. Now we can say this is square root of -1 multiplied by square root of 4. So now it is easy. So this is simply J, and this is ±2. So we can say it's multiplied by, so it is ±J2. Some books, they say they put this J at the end, but we will use J always in front of the number there to denote that it is a imaginary number. So when you say imaginary number, any imaginary number can have a real part and an imaginary part. So shall we say a number like say 3 plus j 5, we say that is the real part and that's the imaginary part. So that's how we define this complex number, and this whole number we say that is a complex number. And complex number not necessarily should have a real part and imaginary part. It can be only the imaginary part as well. So that means the real part is equal to 0. So let's see how we can find another say complex number, or how we can find the square root of negative 81, which we can write as square root of negative 1 times 81, which is equal to j, that is j and times square root of 81, which is plus or minus j9. So this is how we find, or we give a meaning to this negative 81. So addition, subtraction and multiplication of complex numbers are done the same way that we do normal multiplication, normal addition, normal subtraction and normal addition. Now we'll first do addition. We want to add two complex numbers. Shall we say 1 plus j2, that's a complex number, and we want to add 2 plus j5, another complex number. So that's the real part there, and that's the imaginary parts. I'll just say IM, and that's the real part here, the second one, and that's the imaginary parts. So what we do is, when we want to add, we add the two real parts together and two imaginary parts together. So it's quite easy. So 1 plus 2 plus j 2 plus 5. So your answer will be 3 plus j 7. So the rule in addition is you always add the real parts together and the imaginary parts together. You can't mix them up. So if I take another example, say example number 2, say first number is 10 plus j 5, and the second number is minus 2 minus j 3. So now I add the two real parts together. So that's 10 minus 2 plus, and I'll add the imaginary parts together. So that is 5 minus 3. So that gives us 8 there plus j. That gives us 2. That's the answer. So addition is quite straightforward, and subtraction also similar. Shall I take these same ones there, or we can take different ones? So I'll write the first one. First number is 5 plus J6 and to subtract 3 plus J3. So we subtract the two real parts, that is 5 minus 3 plus J6 minus 3. Sorry, 6 minus 3. So final answer will be 5 minus 3, that is 2, plus J6 minus 3, that is 3. So you have to be careful when you what you have in the signs of these numbers, and then when you open the bracket, multiply by the sign in front and do the subtraction. So it's quite simple, quite straightforward. And then we will do another example. Example number 2. I will take this example, this two sums there. So 10 plus J5 minus 2 minus J3. So now since there is a negative sign there and negative sign inside, so let's open the brackets so that we will not mix up this. So you have to multiply by this, so that is negative negative positive 2 and negative negative positive J3. So it becomes simply 10 plus 2, that is 12, plus J5 plus 3, that is J8. So that's the answer. So let's go on to do